Okay, so back to this activity. And the crystals on the semi-solid, they'll also just drop kind of everywhere, and then they're just going to measure the circle around each crystal, or just pick a crystal and measure the circle around it. Okay, excuse me, so the third one is diffusion through a gas. So this one's kind of fun, actually. This is the smelliest stuff I have back there, so it's Lysol spray. Depending on the semester, you may have Windex, you may have perfume. Right now we're going to use this. And so you're going to pick a student who thinks they have a pretty good nose, and you're going to open this bottle and let them smell what it smells like, so they know what they're getting, and then let them clear their nose so they don't have the smell in there. And then you're going to stand over on one side of the classroom, and you're going to stand them sort of in the middle of the tables, maybe a little more than halfway down the classroom, and you're just going to spray the material, and maybe just spray it kind of straight up so it's not going out. Spray the material and have somebody at the same time, someone else in the lab that you've asked to time it. So they're going to just time on their watch or their phone, time it, and we're waiting for the person to say, oh, I smell it. As soon as they smell it, you stop the time, and I would write on the board, so like, okay, how long was that? Okay, so that took 23 seconds. And then you're going to take your tape measure, and you're going to measure from you to where the person was standing. And let's say, you know, they were, I don't know, 17 feet away. Okay, so it went 17 feet in 23 seconds. And so it actually asks them, oh, I'm sorry, I've actually got 4 people. So line 4 people up, one in the mid-room, one in the next, and one at the very far end of the room, and wait till they each say they smell it. All right, and then you're going to have it, though you'll notice in feet per second, they need to convert it to millimeters per hour. And this is a great practice for them. Students have a really hard time with conversions. This is proportional reasoning, and they stink at it. So I would let them struggle with the conversions for a little bit, but help them out. You know, you may have to get a conversion on your phone or whatever to do feet to the metric system. You get it into millimeters, and the hardest thing they have is with the seconds. So 23 seconds to an hour, and it's funny, you're, okay, 60 seconds in a minute, 60 minutes an hour, so it's 3,600 seconds in an hour. So help them, but let them struggle a little bit with this so they get their conversions right. And what you'll find is that it travels obviously the slowest in a semi-solid, medium in a liquid, and fastest in a gas. So at that point, when you've gathered the data, and everybody's gathered the data, and it should only be about 20 minutes or so, because they should set up maybe 30 minutes. They're setting up their stuff. And they can go on and move on to the next activities, but when everybody for sure has finished activity 1, you need to stop and have a discussion and say, okay, so we see that a semi-solid is slower than a liquid, which is slower than a gas. And the question is, why? Now they all intuitively know that things travel faster in air than they do in liquid than they do in solid, but you want to ask them to explain that. What's going on as far as the actual molecules go? And I like to have them demonstrate. So I say, okay, show me with your hands molecules in a solid. Okay. Show me with your hands molecules in a liquid. And then show me with your hands molecules in a gas. So it's all over the place, right? And students laugh and think it's silly that I use jazz hands, right? So we've got it all over the place. And so you can talk to them about how it's not like directional. It's not like the liquid or whatever is like purposefully moving in one direction. It's just that the molecules are bouncing around so quickly that the molecules are being bounced all over the place very quickly also, and that's why it can diffuse so quickly. And then you might ask them, what if we were to have dropped the KMNO4 into hot water instead of cold water? This is a good application question for them to just apply what they just learned to this and let them stew over it for a second. Hopefully they come to the conclusion that in hot liquid, if this is liquid, here's cold liquid, here's hot liquid, right? So it's hot liquid, it's going to diffuse much faster. Have them test it if they want to. We may have to heat up on a hot plate, but we will have hot plates in the back to do the Benedicts. So you might just have them pull some of the liquid out of the hot plate, out of the beaker that's boiling, and try it, okay? And prove it. Okay, so that's activity 1, and I'm actually going to show you the liquid, what it looks like, and then, oh, by the way, so on the next page, it asks them to draw what's happening to the KMNO4 crystal, right? So we're going from this kind of a situation, this is the crystal when you place it in, we're going to this kind of a situation. And why? It's not because they're repelling each other. It's not because they're purposely trying to spread out. That's something I like to anthropomorphize everything, make it like human brain is, they're controlling themselves. It's not, it's all random molecular motion, but due to random molecular motion, as the molecules bump into each other, they're bound to spread out, okay? And that labels that as diffusion, so there's your first term. This is simple diffusion. Okay, so once they've done that, they're gonna go back and look at their liquid. I'll show you that in just a second, and then we'll start activity 2.